Army units are increasingly vulnerable to high-tech jet attack aircraft. Protecting the Army against the air threat is the job of the Air Defense Forces. This video ordnance program looks at the United States Army's air defense artillery and the star of that branch, the Patriot air defense missile system. As ground attack aircraft have grown more sophisticated, they have posed a greater and greater threat to Army units. Precision-guided munitions give aircraft the ability to destroy even the toughest targets, such as tanks. To protect itself against the aircraft threat, the U.S. Army depends on its air defense artillery branch. Air defense used to be primarily guns, but since the late 1940s, missiles have become the dominant anti-aircraft weapon. The Nike Ajax was the Army's first anti-aircraft missile. It was designed to defend cities against high-flying bombers.
Nike Ajax were static missiles. They were placed around permanent installations, primarily around metropolitan areas, defense areas, and things like that. They were not intended to be mobile. They were fixed in batteries of 4 to 8 missiles in concrete bunkers and were static defense positions against supersonic planes, supersonic bombers.
The Nike Ajax was followed by the Nike Hercules, a more sophisticated high-altitude missile system which is still in service in some countries today. As missile technology progressed, it became possible to build more compact missiles that were mobile. They were no longer limited to city defense, but could accompany the Army units into the field and defend them against enemy aircraft.
Hawk answered that need at the time for what would be called today a medium air defense system, again with a supersonic capability that the traditional medium air defense weapons did not have. Prior to this time, you had a variety of what we call medium range guns, to include the 75mm Skysweeper, which again did not quite fill the bill as far as an adequate medium range air defense system. The Hawk at the time was conceived as that medium range defensive capability, and of course is still with us. It's gone through at least 3 phases now and is still being used.
New guidance technology permitted smaller and smaller missiles, better suited to accompanying Army units right up to the battle zone. The Sidewinder missile, a standard aircraft dogfighting missile, was adapted to the anti-aircraft role as the chaparral. Not needing the elaborate network of radars found with the longer-ranged Hawk system, the chaparral is more mobile. It can serve up front and protect armor and mechanized infantry units. The chaparral missile has a tiny infrared seeker in the nose, which homes in on the heat given off by jet aircraft. One of the most remarkable developments in air defense missiles was the man-portable missile. The first of these was Red Eye, followed in the 1980s by the more advanced Stinger. Stinger employs a very sensitive heat-seeking guidance system which enables it to home in on attacking aircraft and helicopters. The use of heat-seeking guidance on these short-range missiles has led many air forces to adopt countermeasures, such as flares, in an attempt to confuse and decoy the missiles. In turn, to counteract such tactics, the new ADATS missile uses laser guidance, which cannot be bluffed by flares. Air defense missile technology is a never-ending contest between the aircraft designers, attempting new ways to jam and confuse anti-aircraft missile guidance, and the missile designers, trying to overcome these new tactics. The use of different types of missiles using radar, infrared and laser guidance makes it difficult for an aircraft to penetrate modern air defense networks. The U.S. Army uses a layered air defense from the Stinger to the new Patriot missile.
Well, the U.S. Army, like most military forces, fields a complementary mix of air defense systems designed to counter different threats. At the low end of the spectrum, we start with the short-range air defense systems, primarily the Stinger, a man-portable weapon, which is very short-range and is a heat-seeking missile. And then we go up to the Vulcan cannon and the Chaparral missile system, which are again short-range components. We are bringing on a new system called the Avenger, which takes the Stinger missile and puts it in a mobile vehicle with a soldier-operated turret. And then beyond the short-range air defense systems, we have two primary, what we call HIMAD, or high to medium altitude systems. The first is the Hawk system, which is a radar-directed system, and we get into a range there of about 40 kilometers. And then, of course, what we feel is the centerpiece of our HIMAD systems, which is the Patriot system, which is the newest and most modern and has the greatest capability, and its range is out to about 160 kilometers.
In the 1960s, the U.S. Army began to develop a new missile system which could fulfill the roles of both the high-altitude Nike Hercules and the medium-altitude Hawk missiles. This new air defense system emerged in the 1980s as the Patriot. Radar is the only reliable guidance method for long-range air defense missiles, so it formed the center of the new Patriot system. An advanced phased array radar was selected for the Patriot, the first such use with a mobile land-based missile system. Conventional radars emit a constant beam of radiation which can alert an enemy pilot and permit the aircraft to try to jam the radar. The Patriot's phased array radar uses rapid beams that search the sky so quickly that an enemy aircraft doesn't even know it's being tracked. Thousands of times a second, the radar's computer triggers these beams in different directions, memorizing where each aircraft was last spotted. In older systems like the Hawk or Nike Hercules, several radars were needed to search for the aircraft, to track it, and finally to guide the missile against it. On the Patriot, all these functions are performed by the single phased array radar. In spite of its sophistication, computer-controlled operations make the Patriot easier to operate than older systems, and it needs a smaller crew.
Comparison-wise, Nike Hercules and Patriot are the difference between night and day as far as the operator is concerned. With the Patriot system, we're using the computers on board the system to take control of the mundane tasks that had to be performed manually in the Nike Hercules system. With the Nike Hercules, to get a missile in the air, you had to go through a series of crew checks, adjusting meters, potentiometers, peaking and aligning the system. That took time. And it was a single-shot missile. With Patriot, that stuff happens automatically in the flash of an eye, and all the operator has to concentrate on is looking at his display, determining which targets are hostile, and engaging those targets in a timely fashion.
The sophisticated radar used in the Patriot system permitted the use of a novel guidance technology in the Patriot missile. After launch, the radar guides the missile near the target aircraft. In the final seconds before impact, the system triggers a track-by-a-missile control. The missile itself transmits data back to the radar, telling it what it sees. This allows for very precise final guidance corrections, with the missile detonating very close to the target aircraft. Such a technique makes it very difficult for the aircraft to evade the missile. either by electronic jamming or aerial maneuvering. The basic combat formation of the Patriot is the battery. A battery contains all of the essential equipment for a Patriot missile to operate in the field. There are 5 essential types of equipment in each battery.
We've got the phased array radar, which is the eyes of the Patriot system, the engagement control station, which is the computer system housed inside a van where the officer and the non-commissioned officer inside that actually do the engaging of the hostile aircraft or missiles. We have the electronic power plant, which provides the electrical generated power for those 2 pieces of equipment. An antenna mast group, which is used to provide tactical as well as voice data to not only our sister batteries but also our higher headquarters. We have the launcher station, downrange, which is the muscle behind the Patriot missile, obviously one of the most photographed pieces of equipment in the Patriot battery. And those are the big 5. That's what basically comprises the Patriot battery. All the other pieces of equipment are used in support of those big 5.
The launcher unit has 4 missiles, each in its own sealed container. Each battery can have several of these mobile launchers.
In the normal fire unit, we have 8. We can have up to 16 launchers per firing battery. A normal crew of 3 in place the launching station and put it to remote before they vacate. The launcher itself is controlled from the engagement control station, which is quite a distance from the launching station itself.
Like the launcher, the phased array radar is not manned, but remotely operated.
There's no operators in the radar when it's actually running. The only time there's anyone out there is when they're doing maintenance on it. The operators are inside the entry control station.
The brains of the Patriot battery is the engagement control station. This vehicle-mounted shelter contains the computers which control the launchers and phased array radar. The station is led by a tactical control officer, or TCO, who sits to the right. High-altitude air defense units such as the Patriot are one of the career opportunities open to women in the U.S. Army.
Okay, during the exercise in Saudi Arabia, we normally had 4 people inside the engagement control station when we were actually doing the engagements. Okay, I'm assisted by a tactical control assistant, and he or she will do the actual firing. Okay, my function is friendly protect, to make sure that he or she does not shoot down any friendly aircraft that might be flying in the area. Okay, the other position is for the 31 mic, or the multi-channel communications operator. Okay, this person is basically monitoring communications on all lines and making sure that the messages and the traffic that's going back and forth over our UHF systems are operational. Okay, and that 4th person is usually brought into the van as a recorder. Okay, he or she may grab a headset, start writing down any messages we might be receiving from higher headquarters, and are also assisting the TCA. Well, their basic function is to assist the TCA and the TCO so that nothing interferes with them doing the actual engagement.
On the radar display, aircraft are identified by different types of symbols, depending on whether they are friendly, hostile, or still unidentified. When a hostile aircraft is engaged by the Patriot missile system, a hexagon appears over the flashing aircraft symbol. The Patriot missile is identified by a small football. When the aircraft is hit, a flashing tic-tac-toe symbol appears.
The nice thing the Patriot offers us is it's not only a very powerful weapon system, but we can train anytime we want because it is a computer. The basic gist of Patriot is a computer system, and just like you go to the arcade to play video games, this system is capable of doing the same thing. So I don't have to have hundreds of aircraft in the sky to train my soldiers. I can actually create video games that simulate an actual combat condition, put it into the computer, and have my soldiers train on that video game itself. So in that sense, yes, it's very easy for us to train our soldiers with minimal assets, as opposed to things like Nike Hercules, where the only thing you saw was what was actually flying in the sky. There were no mock-up simulations.
Defense against airplanes is not the only mission of air defense. Starting in World War II, missiles started to become a problem as well. The bombardment of the Belgian port of Antwerp by German V-1 cruise missiles in 1944 was countered by the high-tech air defense weapons of the day, the radar-directed anti-aircraft gun and the new proximity fuse.
During World War II, specifically October 1944 up until March 1945, the Germans launched a V-1 offensive against the port of Antwerp, Belgium, in an attempt to knock out the port as a logistics base for the armies in Europe. The defense for the port was given to the anti-aircraft forces of the U.S. Army and the British Army to defend against the V-1s. At that time, about this time, the anti-aircraft forces at that time had obtained a good supply of proximity fuses. Now, this was a development that occurred later in the war. A proximity fuse was a device that actually was on the end of an artillery round, which is actually a small radar, which the idea was that when it was fired into the area, it would detonate when it was in proximity to a target. This enabled air defenders to achieve that one-shot, one-kill ratio that has always eluded air defenders up till that time. Another innovation was the use of radar in conjunction with an M9 director, which actually then tracked the target automatically using radar and the director, so the crew, all they had to do was actually fire the gun. It was an automated system, which is, of course, revolutionary for its time, and again, it contributed to the high success rate the air defenders had against the V-1s. Of about 5,000 V-1s known to be launched against Antwerp, only about 200 ever reached the target. It was an incredible bit of firing.
Although Army anti-aircraft guns were successful against winged cruise missiles, they could not shoot down the much faster ballistic missiles of the day. It wasn't until the 1960s that the first successful tests to shoot down tactical ballistic missiles were conducted by the U.S. Army. As seen here, a Hawk missile was used to shoot down tactical ballistic missiles in a series of experiments. Serious attention to the tactical ballistic missile threat did not begin until the early 1980s. The Warsaw Pact felt that the Patriot was so lethal that its Air Force would face a nearly impossible hurdle when operating over NATO territory in the event of war. The Warsaw Pact would need to eliminate the Patriot air defense barrier first by means of ballistic missile attack. To cope with such missiles, the U.S. Army began a program to permit the Patriot to defend itself against such tactics.
Well, when the Patriot system was fielded at first in Europe in the mid-1980s, it had only a capability of defending against aircraft. The Army realized the importance that tactical ballistic missiles would play and began to develop a capability to counter that threat. And a couple years after the initial fielding, we developed a self-defense protection capability for Patriot, which we called the PAC-1 capability. However, that certainly wasn't a potent enough capability to defend against all types of tactical ballistic missiles, and didn't allow us a capability of protecting anything outside the actual perimeter of the battery itself. So the Army went ahead and developed what they called the PAC-2 capability, and that capability really gave us a change in the missile, which changed the fuse, so we had a faster acting warhead. It changed the spray pattern of the warhead, and it also changed the software in the system. And one of the things that allows the Patriot system to be adaptable so quickly to changing threat situations is the fact that it is a software-based system. Much as the user would upgrade a computer at home by buying a new disk or tape for software, we can actually change the operating parameters of the Patriot system by doing the same thing.
Tactical ballistic missiles, called TBMs, are more difficult to shoot down than aircraft. Their flight paths are very different from those of aircraft. So the computers in the Patriot control stations needed new software to change the way they scanned the sky for targets.
It's an entirely different target set you're looking at. First of all, even today's modern fighter aircraft are fairly big, with a wide wingspan which gives you a relatively large radar cross-section. The missiles, of course, are much smaller. They're harder to find in the sky and harder to track once you do find them. But the biggest thing is that it gives us difficulty because of the speed of the target. Instead of dealing with an aircraft that we can see at long range and have several minutes to decide if it's a friendly aircraft or a hostile aircraft, to warn other people in the area, and to take all the type of tactical action we do against an aircraft threat, we're faced with very short reaction time against a small target traveling exceedingly fast. And when we deal with the Patriot system, when we fire the Patriot system at an incoming tactical ballistic missile, it's really like a bullet looking for a bullet. And we have closing velocities much faster than you would find if you fired two .30 caliber rifle bullets at each other.
In the PAC-2 upgrade, not only did the computer software have to be changed, but the missile warhead had to be changed as well.
Well, primarily the warhead had to be changed. The fragments in a PAC-1 warhead are fairly small because, as you can imagine, when a warhead is exploded near an aircraft, we don't need very large fragments to be able to make that aircraft go out of control or to destroy it. It's a different story, though, when we're talking about a TBM warhead, a tactical ballistic missile warhead, that it has probably a lot thicker skin. The warhead itself is in steel, so that the fragments have to be larger, and they have to be propelled towards the target at a faster velocity.
In the late summer of 1990, the U.S. Army's Air Defense Center at Fort Bliss began deploying Patriot batteries of the 11th Air Defense Brigade to Saudi Arabia as part of Desert Shield. An Iraqi air attack into Saudi Arabia would have been nearly suicidal with the Patriots present. So Saddam Hussein was more likely to use his modified Scud missiles instead. The PAC-2 upgrade was not even completed when the Patriots arrived in Saudi Arabia.
The system had not had that capability for very long. When we deployed from Fort Bliss in August, we took the Army's entire inventory of PAC-2 missiles with us, and that was a total of 3. We had soldiers with their hands on new software that we had not had a chance to train on before. In fact, the Army was scheduled to do a user test of the PAC-2 software here at Fort Bliss that very summer. We ended up doing that test in Saudi Arabia. None of my officers, none of my non-commissioned officers, and none of the soldiers in the brigade had ever fired a missile against a tactical ballistic missile before. So we were very proud of the training program that we were able to put together and the results of that program as Desert Storm evolved.
On the night of the 18th of January 1991, the Patriot system was put to the test. On the screens in the engagement stations appeared the new symbol, the inverted triangle, meaning an enemy missile was inbound to targets in Israel and Saudi Arabia. To the amazement of many, the incoming Scud missiles were intercepted, the first time that ballistic missiles had been shot down in combat. Lieutenant Jeters was the first woman to command a Patriot battery to shoot down a Scud.
So on this particular night, the Scud was in fact coming to Riyadh, the area that we were located in. Okay, so I'm like, okay, folks, this is the real thing. So, you know, slightly different. I had been in the van before when we had got Scud launches or Scud alerts, as they were called, and this particular night it was coming toward us. So of course, you know, everyone inside the van were tense, and you know, the adrenaline was pumping. So you know, we just sat there and waited. Once the system was configured, we sat down and we just waited for the first TBM to show up.
Being inside is rather frightening because you have no view of what's going on outside of you except for the screen, which is radar showing you what's out in front of you. So, you know, we heard Patriots going off, and you could hear the whooshing sound, you know, Patriots leaving the launchers, but we really had, you know, no idea what was going on around us, you know, within our area. So when I looked on the screen and I saw Patriot going up, I told Lieutenant Jeter, I said, it's one away, and we watched it go up, and we got to confirmed kill on it. And while it crossed my mind to, you know, celebrate, we got it, suddenly there was another one on the screen, and we engaged the second one.
It got pretty hectic in the van. We were checking commo and talking with the higher headquarters, trying to get messages down. Once we started the engagement, I was basically monitoring the party line and notifying my communication site what was going on. It was scary. I'd never been in a Patriot unit when they had fired, and we fired multiple launches, and the van rocked. It was a weird feeling to know it was real and what was really going on.
The battle against the Scuds was complicated by unexpected developments. The Iraqis had modified their Scuds to extend their range, but this made them unstable. As they were re-entering the atmosphere, the modified Scuds were breaking up into 3 or 4 pieces.
A breakup occurred, first of all, as it came back in. We engaged on all those parts. The objective and the commander's intent was, if it's coming in, we take it out. So there was a lot of extra effort dedicated to tanking out not only warhead sections, but tankage that also occurred because of breakup. Okay, this is a skin section from the Scud. You can see at this point here is where the Patriot pellet penetrated the surface itself, and here's one of the pellet sizes that does all the damage.
On occasion, the debris from these disintegrations fell to earth at high speed, causing damage in Saudi Arabia and Israel. But what was remarkable was the very high percentage of hits scored by the Patriot, and the surprisingly few casualties caused by the Scuds.
We talk a lot about the outstanding capabilities of the Patriot system, and it's a great system. We got super support out of Raytheon Corporation, and we were very pleased with the overall results. But it wasn't just the system, it was the soldiers. The soldiers are what made it work. And I'll tell you that the victory in the sands of Saudi Arabia over there started in the sands of the desert out here at Fort Bliss, where we train our soldiers and our Patriot battalions here.
New programs are underway to further improve the Patriot's capability against missiles, and new anti-missile systems are on the drawing board. But in the history of military technology, Patriot will long be remembered as the first to win the battle of missile versus missile.